ವೆಲ್ಕಮ್ ಟು ಕ್ಯೂರಿಯಸ್ ಮೈಂಡ್ ಆಫ್ ಸೈನ್ಸ್. ಇವತ್ತು ನಾನು ಸೆಕೆಂಡ್ ಸೆಮಿಸ್ಟರ್ ಕೆಮಿಸ್ಟ್ರಿ ಯೂನಿಟ್ 4 ಅಲ್ಲಿ ಚಾಪ್ಟರ್ 3 ಅಬ್ಸಾರ್ಪ್ಷನ್ ಅಂಡ್ ಕ್ಯಾಟಾಲಿಸಿಸ್ ಚಾಪ್ಟರ್ನ ಡಿಸ್ಕಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇದು ಬಂದು ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಂಡರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಬ್ರಾಂಚ್ ಆಫ್ ಅ ಕೆಮಿಸ್ಟ್ರಿ ಡೀಲಿಂಗ್ ವಿತ್ ವೇರಿಯಸ್ ಫೆನಾಮಿನಾನ್ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್ ಅಟ್ ದ ಸರ್ಫೇಸ್ ಆರ್ ಇಂಟರ್ಫೇಸ್. ನಾವು the chapter name itself says adsorption and catalysis. Now we know about adsorption. Adsorption, it is a phenomenon of higher concentration of a molecular species on the surface than in the bulk of a solid or liquid. Now we know about adsorption isotherm, a mathematical expression or a graphical representation that relates the amount of gas absorbed on the absorbent at constant temperature and the equilibrium pressure is called adsorption isotherm. ಇದರಲ್ಲಿ ಟೂ ಟೈಪ್ಸ್ ಇದೆ, Freundlich adsorption isotherm and Langmuir adsorption isotherm. In short form we called as FAI and LAI. Now we discuss one by one. First, Freundlich adsorption isotherm. A formula is x by m which is equals to kp power 1 by n. Here x is a mass of the gas absorbed, m is mass of the absorbent, k is the constant, p equilibrium pressure, and n is also a constant. Now we derive the expression for Freundlich adsorption isotherm. You can see the graph here. This is the graph which represents the FAI, means Freundlich adsorption isotherm. Here, the amount of gas absorbed increases rapidly with increase in pressure. Initially, as more and more surface is covered, at the rate of adsorption decreases, hence the high pressure, the graph become parallel to x-axis. Thus, FAI not applicable at high pressure. Now, consider the equation what we have. Now, taking log on the both side, we get log of x by m which is equals to log of k plus log p to the power of 1 by n. Next, log x by m which is equals to log k which is equals to 1 by n log p. Let me consider this as equation number 1. Comparing the equation 1 with y which is equals to mx plus c. This is the one of the form which represented in the graph. This is the slope here, y which is equals to x by m or n. Here you can see the graph. This is when we compare it to the y which is equals to mx plus c expression, we get like this type of graph. A graph of log x by m versus log p. This is log p. Should be a straight line. You can see in the graph. This is a straight line. This has a slope of 1 by n. and interception of log K at low pressure. This is the low pressure. Here is the high pressure. At a low pressure, the intersection is formed. All the points lies on the straight line. At high pressure, a side curvature is observed. This indicates it obey under low pressure. Next, Langmuir absorption isotherm. Langmuir absorption derived a simple absorption isotherm based on the theoretical condition. He made the following assumptions that are the solid surface is homogeneous and has a fixed number of absorption sites. Each site can take one molecule. There is an equilibrium between adsorption and desorption. Adsorption molecule with adsorbent. The adsorbed layer is uniform all over the adsorbent. There is no interaction between the adsorbed molecules. Then this is the derivation of LAI. This can be given for 4 to 6 marks. This is very important in this chapter. Now we will derive the expression. Let theta be the fraction of the total surface accumulated by the gas molecule at any instant. The rate of desorption from the surface is proportional to fraction of surface occupied. Rate of desorption is mentioned as RD, which is equals to theta. Change in theta. Proportionality constant is K. Then the equation becomes RD, which is equals to K d theta. Let us consider this as equation number 1. Next, the fraction of surface available for absorption in 1 minus theta. The fraction of surface not occupied, that is the rate of concentration of a molecule on the surface, is directly proportional to the pressure of a gas and the fraction of surface available for absorption. That is RA is directly proportional to P into 1 minus theta. Next, RA, which is equals to KAP 1 minus theta. This is equation number 2. K is a proportionality constant. Now, at equilibrium, rate of concentration, which is equals to rate of desorption, that is RA, which is equals to RD. Now we have RA and RD equations from 1 and 2. Now we equate this. While equating, we finally get that theta, which is equals to KAP into 1 by KD divided by KA plus KAP into 1 by KD. Here KA divided by KD, which is written as B. Therefore, theta, which is equals to Vp by 1 plus Bp. Ka by Kd is B into P divided by 1 plus Ka by Kd is B into P. This is the equation for theta. Now we want x by m equation also. Therefore, x by m, which is equals to k into theta, x by m, which is equals to k, we have derived for theta. Therefore, this value is substituted here and we get x by m, which is equals to ap by 1 plus bp. Here k into b. K into b is known as a. Therefore, x by m, which is equals to ap by 1 plus bp. Now at a low pressure, bp less than 1, then x by m, which is equals to ap. At high pressure, Bp is greater than 1, then x by m which is equals to AP by Bp. Pp will be cancelled and x by m which is equals to A by B. Next, catalysis. Catalysis is a substance which alters the rate of reaction without undergoing any chemical reaction. Is called as a catalysis. There are two types, homogeneous catalysis and heterogeneous catalysis. In our syllabus, homogeneous catalysis is further uh, other topics will come, but heterogeneous only definition we have. Now we see the definitions of homogeneous catalysis and heterogeneous catalysis. First, homogeneous catalysis, a chemical reaction in which the catalyst and a reactant is in the same phase. Reactant and a catalyst in the same phase. Next, heterogeneous catalysis, a chemical reaction in which the catalyst and the reactant substance are in different phase. Next, adsorption theory of a catalysis. This explains the mechanics of the heterogeneous catalysis, especially when the catalyst is a solid and the reactant are gases. Next, autocatalysis. Sometimes one of the product generated during the reaction itself, catalyst, further the reaction such substances is called autocatalyst process is called autocatalysis. Here you can see the example. Next, unimolecular surface reaction. Here A is adsorbed at the active spot M on the surface. Next, then on activation decomposes into a product. Next, bimolecular surface reaction. A and B are reactant molecules are chemical absorbed at the two neighboring vacant active spots on the surface of catalyst and on activation decomposes into a product.